Welcome to Making and Treating of Steels course. Today I am going to talk about how stainless steel is produced. It is one kind of steel. As of now, we learn about steel production by LD converter process, which are plain carbon steels, and variety of alloy steels can be produced as well as plain carbon steels produced by electric arc furnace. Now I am going to introduce one more point, that how do you produce stainless steel? What are the raw materials used for producing the stainless steel, and what are the grades of steels are produced based on the property and application, and what are the steps involved to produce the stainless steel will be discussed in this lecture. Let me proceed. What are the essential raw materials to produce stainless steel? Especially it is assumed that it is an iron alloy, and there will be many of alloying elements such as carbon, manganese, silicon, sulfur, phosphorus, which are 5 main elements which you will usually find in steel. Along with those things, you will find for the making steel to stainless steel, important alloying element is chromium and nickel. And to improve further properties based on the applications, molybdenum, vanadium, titanium, copper is also added. It is about the raw material part. Why do you add this alloying additions for this part to make steel to stainless steel? Mainly to with respect to the application and specific property. Let us see now classification of the stainless steel, where you will realize the alloying addition with respect to the composition. Few examples. There are steels called as a ferrite stainless steel, which contains minimum 12%, maximum 30%, along with the carbon content. This is about the ferrite stainless steel. It appears the microstructure predominant by ferrite grains. So that is ferrite stainless steel structure. Its application and further properties and grades will be discussed in the next slide. Now you will see that the composition of chromium is varied, alloying addition 12% minimum with chromium. And coming to the martensitic stainless steel, which contains around 13% chromium and with carbon. You will see the chromium variation. In this kind of stainless steel, usually most of the grains are martensitic grains. When you observe microstructure under the microscope, you usually find. Based on that, composition is also related to the microstructure. That is one of the strength of a metallurgical engineer, which can be assessed. And austenitic stainless steel, which contains 18% chromium, 8% nickel. Here you will realize to see nickel is added, whereas ferritic and martensitic you didn't find nickel addition. Here nickel addition is observed. It is also called austenitic stainless steel, 18-8 stainless steel. There are many grades, names are available for stainless steels, 18-8 stainless steel, and more applications. 50% of stainless steels are produced in the world are austenitic stainless steel, and applications also 50%, 50% applications are with austenitic stainless steel and with varying carbon content. And coming to the precipitation hardenable stainless steel, which require in special applications, will be focused in the next slide, which contains 18 to 20% of chromium with addition of nickel, copper, titanium and aluminium. It is mainly the hardness. It is called precipitation. By precipitation, hardenability. is improved. So based on that, it is called precipitation hardenable stainless steel. Similarly, microstructure is having predominantly austenitic grains, parent matrix, martensitic stainless steel, ferrite stainless steel. Coming to the duplex stainless steel, which contains chromium around 25%. Duplex stainless steels is one more category where you need vacuum treatment, further reducing the carbon and nitrogen level. It is called, if the process is two-step process, it is called duplexing process. If it is three-step process, it is called triplexing process, which will be described with complete details in next lecture. And coming to the what is the significance of chromium addition, you will realize to see wherever you find it is mainly talking about chromium addition, chromium allying addition, and allying addition also greater than or equal to around 15%. It means it is an high alloy steels. And what is the importance of chromium? Chromium mainly imparts the shining nature to the stainless steel. You will call it as a stainless, is nothing but there are no stains appeared on the steel, which you will find in kitchen applications mainly. And coming to this particular chromium is very important in production of stainless steel. You will realize from the classification of the stainless steel, and there is no alternative other than chromium to make steel to stainless steel. So one need to note this particular point. These kind of concepts and points are important for gate examination and viva questions. And chromium, usually the element chromium metal inherent nature is it is hard and corrosion resistance transition element. That is why it is used to improve. CR stands for corrosion. You can remember like this, corrosion resistance. It improves corrosion resistance. Now, in generally, it is said that higher the chromium, higher the corrosion resistance, or more the corrosion resistance. Please remember this point. Now, coming to the grades, variety of grades, and there are kind of grades called austenitic stainless steel grades and martensitic stainless steel grades and ferritic stainless steel grades, precipitation hardenable grades, and there are many grades of steels. You will be understood from this slide. These are the variety of grades, and let me focus on grades and properties on this particular slide. Remember, there are types of stainless steel as explained: austenitic, ferritic, martensitic, and precipitation and duplex stainless steel. And there are grades. You usually find austenitic stainless steel with 300 series and ferritic martensitic stainless steel you usually find with 400 series, and precipitation hardening stainless steels 17-4 pH. With this grade, duplex stainless steels are observed with 2205 grades. These are the example grades and types of stainless steel, and there are properties different from different grades and applications. Based on the grade, it is suited for variety of application. You will be understanding from this slide variety of grades and types of stainless steel, properties and application. Remember this particular point for gate examination as well as the viva questions. Types of stainless steel and grades. 300 series means it is austenitic stainless steel. 400 series, it could be ferritic and martensitic. It usually varies with number. 400 and 409 is ferritic, and 410, 420 as given examples here martensitic. Remember these numbers. And precipitation hardening easy to remember. It appears like a number and dash another number and pH grade. Sometimes they will show, sometimes they will not show. And you will see 4 number grades, that is duplex stainless steel, easy to remember. Remember these things which are important for gate examination, and remember with one property and one application, at least one property, one application, which I am going to emphasize now. For example, if 301 austenitic stainless steel, usually it shows good amount of strength and ductilities, and which are improved by various forming methods such as rolling, extrusion methods, and hot rolling, cold rolling methods improves strength and ductilities. You can go for those forming methods. You can choose 301 series, and by those forming methods you can convert suitable to automobile components, automotive components, these things. And let me take one more example from ferritic stainless steel 400. Mainly it gives good surface finish to stainless steel. It is assumed if it is ferritic stainless steel, it usually have the good surface finish. That is why wherever the surface finish is required, there ferritic stainless steels are preferred. And coming to the martensitic stainless steel 410 grade and 410H, 410HC and 304LH. L stands for low carbon content, H stands for high carbon content, HT stands for very high carbon content. And coming to the martensitic stainless steel grades, it usually has better hardenability. That is why this kind of stainless steels are suitable in applications bolts and nuts and screws. Coming to the precipitation hardening stainless steels, it has high strength and high hardness. Just like austenitic steel, high strength and ductility, it has high strength and high hardness, because of precipitation hardening imparts high hardness. That is why these kind of stainless steels finds in applications such as aerospace components. Now coming to the duplex stainless steels, it has good resistance to chloride environment such as ocean, stress corrosion cracking. It provides resistance to stress corrosion cracking. That is why this kind of stainless steels find suitable application in heat exchangers. These things one need to remember, one application, one property, and these grades which are very important with respect to the viva questions and gate examinations. Now let us know about stainless steel production process. What are the steps consist of, what are the step by step, which steps comes forward, which is ladder. So all those things will be understood in this step. Now first step is you need to melt raw material. You choose, usually electric arc furnace is suitable. You choose raw material. It could be the stainless steel scrap, it could be the ferrochrome, it could be the high carbon and ferrochrome and addition of allying additions. Everything is done at the stage of electric arc furnace. And to become molten state, it will take 8 to 12 hours. Intense heat need to be supplied by initially electric arc with applying the lower voltage, slowly increasing the voltage. Finally it is reached to the molten state. Now coming to the tuning process. Why do you need to tune? Based on the applications, usually you will find that there are variety of applications which are required quality, which demands the quality. How do you achieve the quality? And based on the demand of application, it is mainly by fine adjustment. It should be exact chemical composition. It will be done after reaching to the molten state. Fine adjustment of compositions done. That is second step. Now these particular things, tuning is done. How do you do it? Slowly stirred with mainly inert gas, unwanted elements are removed, and maintaining the consistency of chemical composition and within the temperature limit. Temperature is also, molten temperature is also important, which will be done tuning process. This is how the tuning is done in the stainless steel production process. Once molten metal and tuning is done, it is ready to forming operations, to be carried out forming operations. Before forming operations, you need to take molten steel and cast. You will be taking this molten steel in ladle, taken into the continuous casting shop in industry sections. It is been casted in the form of variety of size. Those forms are, it could be blooms form, the cross section you will see rectangular shape, and billet form, the cross section will be square shape, and slabs which are flat shapes are produced by continuous casting methods. After this continuous casting method, which is nothing but semi finished form, it will be taken to the final shaping into the art rolling process. Next step is art rolling process. Here the temperature is very important. Usually above recirculation temperature is chosen. The precise temperature is also chosen with respect to the stainless steel grade, whether it is ferrite grade, whether it is martensite grade. The temperature is also chosen, lower temperature, higher temperatures, all those things usually you will find in more information textbooks. And these particular forms are made by these particular eye rolls. By passing these semi finished goods through eye rolls, convert into the following shapes. Those shapes could be from blooms and billets to bar and wire. It is been converted by art rolling method. It was bloom and billet. Similarly slab, these particular slabs are converted into plate and sheet form. And the further step is cold rolling. Why do you require cold rolling? For example, if surface finish is required good and precise dimensions are required based on the applications, then you need to choose cold rolling. Otherwise cold rolling step can be skipped away. And this is many applications find surface finish. This particular cold rolling process is also temperature important phenomena. Below recirculation temperature is chosen for the steam to operate this operation. Usually you will find a small diameter roll, then the hot rolling process with some supporting rolls are chosen in cold rolling process in industry. And wide sheets are produced using cold rolling process, converted those hot rolling. After hot rolling, this cold rolling is taken place. Hot rolling products are taken and increasing wide sheets with good amount of ductility and good surface finish is achieved. Now annealing process is also important. Why do you need annealing process? For example, the material is application find that it should have high ductility. The grain structure supposed to be refined grain structure or smaller grain structure. You can achieve by annealing process, by softening method, which is called softening process. How do you do? And you can also do, or you can remove the internal stresses, residual stresses by the mechanical operations. Usually mechanical operations, semi-finished goods casting operations induce residual stresses in the material. These things will be removed at annealing steps. This is compulsory steps for any of the operations. And this annealing process is done in a controlled cooling conditions, which is nothing but furnace cooling. is there will be a box, large box type cooling which are stayed for 1 hour and 2 hours depending upon the application and grade of the steels and subjected to annealing process. Annealing process, one of the disadvantages of annealing process is it leaves scaling on the goods, on the products. How do you remove the scale which was formed by annealing process? You choose suitable descaling operations such as pickling operations. Pickling is nothing but taking the acids such as nitric hydrofluoric acid and dipping these particular large length bars and rods as it is formed and dipped into that state for an hour, and you will find that the scale is removed, dissolved in the steel, and you will take out those particular goods and taken into the atmosphere. That is nothing but scaling up. Scaling is done. There are other methods, electro cleaning, where you will send the electric current to remove the scale. That is alternative method. Now coming to the cutting operations, it doesn't mean that the long length rod, long length wires are kept as a form of finished goods and it can be sent to the further applications. It need to be cut into the suitable size. Cutting operation also is important. Usually mechanical cutting is chosen, but there are variety of cutting methods available such as straight sheared with guillotine knives. These are the inclined knives will be there either of the side, and that particular rod or sheet will be passed through it in a this particular straight sheared. With the shearing mechanism it is been cut into the pieces. Similarly there will be a circular shape. There are another method called plasma jet cutting. These are the variety of methods chosen in industry based on the economic conditions, based on the scale of industry, private scale and large scale industry, small scale industry. Variety of operations, affordable operations are chosen for cutting. And finishing operation, last final operation is surface finish. In why the surface finish is important? Most of the people, whenever they go for buying the consumer goods, they will see appearance. How does it appears? Whether it attracts with a good surface finish and shiny or not. It is usual tendency of human being. Even the for large applications also it is observed. The number of finishing operations are chosen. The finishing operations usually done by grinding wheels and abrasive belts. It is been smoothened. Finally it is been polished, so that you will see. And there are other methods called buffing with cloth wheels. You will get the very good surface finish. There are many other methods you can go through, and it is understood that the smooth surface finish is also related to the corrosion resistance. If it is smoother, the formation of it could be the aluminum oxide, it could be the chrome oxide, Cr2O3, it could be the aluminum oxide and iron oxide. It will be resisted from formation of oxides from atmosphere. So those things are very important. Now it is the conclusion about today's lecture that mentioned that is it true or false we cannot produce stainless steel in LD converter. Is it true or false? Mention your opinion. Thank you.